In this lesson, we will begin learning the insertion sort algorithm. This algorithm can be very confusing, so before we begin writing the computer code using Java, we're going to first go through the algorithm using an illustration, and I'm going to do that using Microsoft Word. So, in this file, which you can download from the website, you will find that there's a list of numbers. The numbers in this row are the indexes that will be our array indexes. And in the row below, I have put some values into the list. What we will then do is go through the steps using the insertion sort algorithm to put these values into their correct order so that you can understand the process that we're trying to write in code in the next step. The way the insertion sort works is you pick a starting value to look at. It will always be the second element of the array, ignoring the first element for reasons that will hopefully become clear. We begin by looking at the value with the index 1. So, this is the number that we're going to be inserting into our list. Therefore, we'll put that number here because it's the value we're going to be inserting. And because it's in position 1, for the purposes of this illustration, we'll remove that value, leaving that box blank in the list. Next, what we're going to do is begin checking all the values to the left of the value we're inserting. Since, of course, the blank box represents the value that we're inserting, the only value to the left is 26. So the question we need to ask is 26 greater than the value that we're trying to insert? If it is, then we move it to the right and check the next element to the left. Is 26 greater than 24? Yes. So we will move that value one box to the right. Now, it says to check the next element to the left, but as we can see, we've reached our last element. So what we do is we put the value that we're inserting into the empty box. And now, as you can see, we've inserted 24 into the first position. What's the next element that we're going to examine? Well, we were just inserting element 1, so we'll go to element 2. Now, what's the value that we'll be inserting? Well, it's going to be 20, so we'll move that to the value that we're inserting. And then we will begin comparing each of the values to the left of this box to 20. So, the first number that we must compare is 26. Is 26 greater than 20? If so, we move that value one box to the right, and then we continue on. What's the next value to the left? 24. Is 24 greater than 20? It is, so we move that value one box to the right. Once again, we've run out of positions in the array, so we move 20, the value that we're inserting, into that position. Okay, what's our next element? Well, it's element number 3, which has the value 22. So, we'll put that number there, and that's the number that we're going to be checking everything against, so we'll also fill it in there. Okay, what is the first value that is to the left of what used to be in position 3? Well, that would be 26. Is 26 greater than 22? The answer, of course, is yes. So we move that value one notch to the right, and we look at the next value to the left. Is 24 greater than 22? Of course it is. So we move that value one notch to the right. Next, we look at 20. Is 20 greater than 22? If not, then we put the value we are inserting into that position. So 22 goes here. And at this point, hopefully, you're starting to get a picture of how this algorithm works, because as you can see, we have 20, 22, 24, and 26. What's the next value that we have to insert? Well, it is 18. So that's what's in position 4 in our array. So we'll take that value, move it into our box here, and then start comparing it to the other values in our array. Is 18 greater than, is 26 greater than 18? Of course it is, so we move that one box to the right. Is 24 greater than 18? Of course it is, and so we keep going. 22 is greater than 18, and 20 is also greater than 18, and we're out of positions, so we'll put 18 into that empty box. Okay, what's next? Well, our next number is going to be what's stored in element position 5, which would be 28. So let's move 28 into the box, and we're going to be checking to see if an element is greater than 28, starting with the first element to its left, which is 26. Is 26 greater than 28? Of course it is not. So if it's not, we put the value that we're inserting in that position. Now this is the important aspect of the insertion sort. As soon as you find that you put your value back into a box, you don't have to continue checking the rest of the values in the list, because up to this point you know that all the values to the left of the one you just checked have to be lower than the current value. Therefore, all that's left is to check element 6. Okay, so let's take 30, put it into our box, and we're going to be now comparing 28 to 30. 28 is not greater than 30, so we will begin by putting 30 back into the list. And as you can see, I now have a list in sorted order. That is a step-by-step pseudocode version of the insertion sort algorithm. We're going to take a short break, and then we're going to begin putting the code into Java to implement this algorithm.